Module 4, Lesson 16, Write expressions in which letters stand for numbers. All right, taking a look at some learning targets here. This is a big step toward the representing real-life situations using mathematical expressions. Those other learning targets are still out there. We're using the information we've applied, but this is really a big focus of this lesson. All right, so by the time we're done today, we want to be able to write algebraic expressions that record all operations, and we would like to write those expressions using numbers, and we would like to write those expressions using letters that stand for numbers. So one of the things we really need to pay attention to as we prepare to write expressions is we need to be paying attention to what are the key words. Thinking about yesterday's lesson, lesson 15, what are the key words that indicate to us what operations that we are performing? So we're going to be doing some underlining today. And so we have the directions here. Underline the key words in each statement. What are the words that are going to tell us what's happening here? Well, I notice that I have a sum, and I notice that I've got a twice. So the sum is going to tell me that I'm performing an addition operation, and the twice is going to tell me that I am performing a multiplication operation. The quotient of C and D. Quotient is going to indicate to me that I am performing some kind of division operation. A raised to the fifth power and then increased by the product of 5 and C. Now I've got this raised to the fifth power, so that's going to be some exponent tip off to me. And then I have an increased, so I'm performing some type of addition operation. And then I have a product of 5 and C. So a lot going on in that particular expression. The quantity of A plus, I've got addition going on there, and then divided by 4. 10 less than the product of 15 and C. Hopefully you're noticing that a lot of these words were on our vocabulary list from lesson 15. 5 times D, and then increased by 8. So make sure you keep an eye on that vocabulary list. Make sure you're reading these expressions carefully and asking yourself what operation is indicated by these words. All right, so now what we're going to do is look at the exact same expressions, and we are going to actually write the expression. So we're in word form right now, and we want to actually move into a number form. So paying attention again to I have a sum and twice, and now I need to ask myself, what am I summing here? The sum of what? The sum of twice B. So I need twice B, and what is being summed here is the and 5. All right, I have a quotient. A quotient of what? I see my joining word here, C and D. And of course, we have looked in the last few lessons about a bunch of different ways that we could write that division operation, having decided that fractions were incredibly efficient. All right, I have A raised to the fifth power. So the fifth power is going to be with the A here. A raised to the fifth power. And then I have a reading word here. So I have an order. So first I'll raise to the fifth power, and then I will increase it. And I'm going to increase it by the product of 5 and C. So I need to be multiplying the 5 and C. So A to the fifth plus the product of 5 and C. All right, the quantity of A plus B divided by 4. Now this is one of those that we have to read and think very carefully. Am I supposed to do A plus B divided by 4? Or am I supposed to do A plus B divided by 4? And I would argue that this one is a little bit confusing because I can read it both ways. The only thing, I can read it both ways. Because I see the quantity of A, and then I see the plus, and then I see B divided by 4. But I also see it as the A plus B, and then divided by 4. So I would argue that this one is pretty poorly written. In the answer key, they show it as this A plus B divided by 4. But reading the words, I can see it both ways. So let's use that as a reminder that we need to write clearly. If we wanted this second one here, we could add a then. A plus B then divided by 4. And now all of a sudden, we know what's supposed to happen in what order. So as you're writing your own expressions, let's make sure we're clear. All right, 10 less than the product of 15 and C. So I have a product here. It's 15 and C. And I want less than the product. How much less? 10 less. So I have the product and I want 10 less. All right, 5 times D. And once I have the 5 times D, I have a then increased by 8. All right, so now we are moving into real life expressions. Feels like it's taken forever to get here. But we have a real life expression, and we are going to turn it into a mathematical expression. I say real life expression, a real life situation that we are going to represent with a mathematical expression. So Marcus has 4 more dollars than Yassine. So my more there gives me an idea of an operation. And then it says Y. Y is the amount of money Yassine has. And we're going to write an expression to show how much money Marcus has. So I need to think about this. So I know that Yassine has some money. So Y is equal to Yassine's amount of money. And I know that Marcus has more than Yassine. So whatever Yassine has, Marcus has 4 more. So it says in here, Y is the amount of money that Yassine has, and Marcus has 4 more than Yassine. So I'm going to take what Yassine has and add 4, representing a real life expression, a real life situation with an algebraic expression. All right, Mario is missing half of his assignments. Half is kind of a key word in my brain here. Tells me I've either got some kind of division going on, or I've got some kind of multiplication because it's half of. A represents the number of assignments. So here's my variable. So A is total of assignment, total number. And I'm going to write an expression to show how many assignments Mario is missing. Well, I know that half of the assignments, and A is going to be the assignment, so I want half of A. A is the total number of assignments. Half are missing, so I want half of the number of assignments. All right. Camilla's weight. I'm going to go with Camilla. Camilla's weight has tripled. Oh, see, there's another multiplying word there. Tripled since her first birthday. W represents the amount Camilla weighed on her first birthday. W is weight on first birthday. And we are going to write an expression to show how much Camilla weighs now. Since her first birthday. So I have her first birthday, and she weighed this much. And since that time, a tripling has occurred. So her weight is triple what it was on her first birthday. All right, Nathan brings cupcakes to school. Cupcakes. And gives them to his 5 best friends who share them equally. So C is the number of cupcakes Nathan brings to school. Now I want you to notice that I am taking the time on each of these problems to write down what I know, indicate my thinking here. And I am supposed to write an expression to show how many cupcakes each of his friends receive. And so he's sharing these amongst 5 friends. Now, what operation goes with sharing? Well, this would be division. Now, I know that for many students, division is a tricky one. So it may be that you even want to draw a model to help you out here. He's got some cupcakes, and he is going to share them out amongst 5 friends. So he has taken his cupcakes, and he has split the pile, split the group of cupcakes amongst 5 friends. And of course, I always wonder, well, did Nathan get one of these cupcakes? So if Nathan took one too, then in my head it'd be, well, the cupcakes divided amongst 6. But Nathan probably had his cupcake at home and probably didn't bring it to school. But I always wonder that. Resist the urge to overthink it. They said 5 best friends, so we'll probably divide by 5. Mrs. Marcus combines her atlases and dictionaries. Combines her atlases and dictionaries and then divides them among 10 different tables. A is going to be the number of atlases, and D is the number of dictionaries. So A equals number of atlases, and D is equal to the number of dictionaries. And it says we want to combine those. So I have combined the number of atlases and dictionaries. And it says after they are combined, she is going to split them amongst the 10 tables. And splitting or dividing is a division operation. So each table is going to have 1/10 of the combined dictionaries and atlases. So I could potentially write it this way, remembering the connection between division and multiplication with fractions. All right, to improve in basketball, Ivan's coach told him that he needs to take 4 times as many free throws and 4 times as many jump shots every day. So F is the free throws. F is equal to number of free throws. And J is equal to the number of jump shots. Okay. And I need to write an expression to show how many shots he will need to take in order to improve in basketball. Well, I know that the total number of shots he shoots every day is the free throws plus the jump shots. And I noticed that the coach wants him to multiply both of those by 4. So I could combine the free throws and jump shots and then multiply them by 4 to indicate how many he's supposed to be taking. Now, it's very possible that you wrote the expression 4F plus 4J. This is mathematically correct. It will help you find the total number of shots to take each day. However, remember we have worked on using the distributive property and factoring to write expressions in this form, the factored form, where over here we have the expanded form. All right, taking a look at some exercises here. And we're going to mark the text by underlining keywords and then write an expression using variables and or numbers for each statement. So I have decreased and I have a squared. The squared goes with the C, so I have C squared. And it says B is decreased by that. So B is decreased by B minus C squared. And there is a part of me that says you could read this B decreased by C and then squared. Once again, the importance of being clear as we write expressions out in words. 24 divided by the product of 2 and a. So I have a product of something and something is divided by it. So I have a product of 2 and a, and 24 is divided by that product, 2 and a. 150 is decreased by, so 150 will be decreased by the quantity of 6 plus b. And I'm going to propose here that we should probably put in some parentheses. Because we want to have the 6 plus b and then decrease it. So we will combine the 6 and the b and then take it away. Otherwise, what we wind up doing is taking 6 away and then adding the value of b back on rather than subtracting off the value of b. Oh, I should step back here for a second. My eyes were looking here at this problem. I noticed the greatest common factor of these two is 2 and 2, and I would be left with 12 divided by a if we wanted to simplify that down. The sum of twice c and 10. So I've got a sum, and what am I summing? Twice c and 10. So twice c and 10 will be added together. Marlo had $35 but spent M. So here we are with a real life situation. So Marlo had $35, but he has reduced the amount he has by spending the amount M. Samantha saved her money and was able to quadruple the original amount M. So I had M, Samantha had M, and she quadrupled it. All right, Veronica increased her grade. And they've given us a variable here. G is Veronica's grade. And she increased by 4 points. And after she had increased it by 4 points, then doubled it. See, I love these words here. It gives me some idea of order. So she had a grade. She increased it by 4. And after she increased it by 4, she then doubled it. Yes, we need the parentheses on this one to indicate that she first increased by 4 and then she doubled it. Ed Bell had M pieces of candy and ate 5 of them. Then he split the remaining candy equally among 5 friends. So we had M, so M is number of pieces of candy. And we've got an eating, and then we have a splitting. So we have some candy, and we eat 5 of them, which will reduce the number of pieces of candy. And then we are going to split them amongst 4 friends. If you wanted to write this horizontally, you would have to use parentheses to indicate that the subtraction occurred first. All right, to find out how much paint is needed, Mr. Jones must square the side length S of the gate and then subtract 15. So I notice that we have a squaring going on, and S is the side length of the gate. All right, so it says first I need to square the side length and then subtract 15. Luis brought X cans of cola to the party, so X is number of cans of cola. And Faith brought D. And I guess I probably need to indicate here this is Luis and this is Faith. And Deshaun brought H cans. I'm running out of room. Okay. And it says, how many did they bring all together? All right, so I've got Luis's that will be combined with Faith's that will be combined with Deshaun's. All right, so taking a look here, how is writing expressions with variables and numbers similar to writing expressions using words? It's the same vocabulary words. The vocabulary remains the same. We do need to identify the parts of the expression before writing the expression. It's helpful to look and say what is actually happening here. How is writing expressions with variables and numbers different than writing expressions using words? When an expression with words is provided, it is possible that it might be represented mathematically in more than one way, and this gets back to the confusion. We looked at a couple of examples where we read it and we thought, oh, it could mean this, oh, it could mean this. When we write expressions algebraically using numbers and symbols and variables, and we skip the word part, we have to follow the order of operations. It makes it very clear what needs to happen. All right, so a quick look at the I can statements. Hopefully by the time you are finished with this lesson, you can write algebraic expressions, recording all operations that have numbers, and also using variables. And it kind of bugs me that I used algebraic expressions here because we also used numerical expressions. We didn't have variables in there. So maybe I need to rewrite that. And then one of our big learning targets here, representing real-life situations using mathematical expressions. Just worked through a whole bunch of those. So been building toward this big progress moment. So at this point, you should be finished with Module 4, Lesson 16. Go ahead and do your problem set. If you have questions, make sure you talk to your teacher.